Well, good evening, everyone. Welcome to day 2 of chapter 8. Hopefully you are doing well with learning how to graph rational functions. We have talked about horizontal asymptotes and vertical asymptotes, and today we want to talk about x and y intercepts. So we have done both of these before on several other graphs, so hopefully this won't be anything too unusual for you. I'm going to jump right on in, so maybe my video won't be forever long. I know you guys are thrilled about watching forever long videos, but we'll see what I can do to make them a little bit more short. So our learning target is to be able to find x and y intercepts on any of our rational functions. So if you'll take a look at these, to find a y-intercept, of the graph of a function, we plug a 0 in for x. That's how we find any y-intercept. So you let x equal 0 and solve for y. And we've been doing that for a while. Sometimes it's easy, sometimes it's hard. And in this case, I think you'll find the y-intercept is pretty easy. You just have to be able to keep up with a few things. So example number 1, letter A, it asks you to find the y-intercept of each of the following. So what I'm going to do is substitute the value of 0 in for every x that I see. Now, f of x, remember, is your y equals. So if you remember that, you can go ahead and change it if you want to, and that'll tell you what your y-intercept is. So I have 2 times 0 squared minus 12 over 0 squared minus 13 times 0 minus 48. Well, 0 squared times 2, that value is 0, minus 12. So that's going to tell me that the numerator has a negative 12 in it. And the denominator, I have 0 minus 0 minus 48. So I have a negative 48 in the denominator. So my y-intercept is this value simplified. So 12 divided by 48 is 1/4. Now, if you remember, all of our y-intercepts that you have done for me this year have always been 0 for the x and 1/4 for the y. It is a point where you cross the y-axis. So if you were going to draw the beginning part of this, your y-intercept of this particular graph would be at the point 0, 1/4. So it would be down kind of low on the graph. We're not asking you to do this part right now, but I just wanted to show you where it was. All right, moving on to the next one. Now you'll find out that the more of these you do, the faster you can do it. Remember, g of x is the name of the function, so we can let that be y equals. And then if we'll let 0 be substituted for every x that we see, I'll have a 0 plus 18, or an 18 in the numerator, and a 0 plus a 0 minus a 0 minus a 6, or a negative 6 in the denominator. And if I simplify that, I have y equals negative 3. Now you are more than welcome to pull your calculator out and do that. Do that simplification. You don't have to do anything by hand. So 0, negative 3 is your y-intercept. And of course, you don't have to write the whole thing out, but teacher Miss D says, let's do it. Anyway, that's how I find the y-intercept. Now, to find the x-intercept of one of these rational functions, we have to do something that's probably a little more challenging. So to find the x-intercept of the graph, of any graph, not just a rational function, we're going to plug 0 in for the y. Or a lot of these cases, they're going to be f of x or g of x or whatever. But it is the y value. Or a shortcut for finding the x-intercept is to set the numerator equal to 0 and to solve it for x. Now, there's going to be a reason for that, and I'll show you why on the first example. Okay, so when I'm looking for x-intercepts, I'm going to let the y equal 0. So what I have is 0 is equal to x minus 4 over x minus 1. And what I'm trying to solve is for x. Now, I'm going to say 0 over 1 is the value of 0. And because I have fraction equal to fraction, the way that I solve what's called a rational equation is I'm going to cross multiply them. So what I have is 0 times x minus 1 is equal to 1 times x minus 4. Well, here's the part that's so nice about solving these for x-intercepts. 0 times this is 0. And so 1 times x minus 4 is x minus 4. And if you take a look at that, you'll see that this is the numerator. So this second little part that says the shortcut for finding the x-intercept is to set the numerator equal to 0, that's the reason why. So if you understand the shortcut, I don't have to set everything equal to 0 and cross multiply. All I have to do is remember to find the x-intercept, set the numerator or the top equal to 0, and then solve. That's the shortcut. So that is the shortcut for finding the x-intercept. Now, sometimes there are 1, sometimes there are 2 x-intercepts in an equation. So it just depends on what your equation looks like. So if I want to solve this one for the x-intercept, all I need to do is add 4 to both sides. And then what I find very quickly is x equals 4 is the x-intercept. And remember, when I note x-intercepts or y-intercepts, they should always be in an ordered pair form. So the 4 is the x value, and the y is the 0 is the y value. And this is the calculation of the x-intercept. Moving to the next one. It's kind of a cool one because when I look at this, there's a 5 at the top. There is no variable. So if I went through that same process again and I let the y equal 0, 0 over 1 is equal to 5 over x minus 2. When I cross multiply those, 0 times x minus 2 is equal to 1 times 5. Okay, well, 0 times x minus 2 is 0, and 1 times 5 is 5. And is 0 equal to 5? And the answer to that is, hey, no, that's not true. That's not true. So then what's going to happen with this? Well, there is no x-intercept. So that means if I graph this particular graph, it never touches the x-axis, which we all know that there have been cases in the past where that doesn't happen, where we don't cross any point on the x-axis. So, hey, that's it. So I have one more example for you, and this is to practice both of them, to practice an x-intercept and a y-intercept. It says to try it on your own, of course. So if you'd like to stop the video, try it on your own, go for it. Otherwise, here we go. Okay, let's do the first one. Let's find the y-intercept first. That seems to be the easier one. So the y-intercept, remember to find the y-intercept, I'm going to let x equals 0 and solve for y. All right, so in my particular equation, I have y equals 0 minus 9 over 0 minus 1. So the 0 squared is what I had. Well, that's still 0, and 0 minus 1. So my y value is negative 9 on top, and 0 minus 1 is negative 1 on the bottom. And so what I end up with is a positive 9. So my y-intercept was 0 for x and a 9 for the y. And that's going to tell me my y-intercept. Pretty simple, huh? Well, then I'm going to move to find, and I'm going to change to blue for this one. I need to find the x-intercept. So to find the x-intercept, I need to let the y equal 0. So we'll say this again. So to find the x-intercept, let y equal 0 and solve for x. Now there's a shortcut. Don't forget the shortcut. The shortcut says set the numerator and the numerator is the top. Don't forget that. Equal to 0 and solve. So I'm going to go with the shortcut because I'm a big fan of shortcuts. So here's what I have. To find my x-intercept, I'm going to say x squared minus 9 is equal to 0. And if we're going to solve that, we have our choice. Factoring, that's my first choice. Algebra, quadratic formula, or we can do graphing. So I'm going to tell you that I recognize this right away as x minus 3 times x plus 3. And therefore, I know that this x minus 3 equals 0, the x plus 3 equals 0, and this one is a positive 3, and this one is a negative 3. So I do have two values for my solution. I knew that because it's a squared. Remember that the exponential value tells me how many solutions I have. And so my two x-intercepts are 3, 0, and negative 3, 0. Those are my x-intercepts. Now, some of you may be saying, well, you know how much I love factoring. Do I have another option? And the answer to that is yes, you do, absolutely. Quadratic formula is always an option, or you could always use algebra for this. So if x squared minus 9 is equal to 0, I would add the 9 to both sides, and x squared then is equal to positive 9. And if you take the square root of both sides, then x is equal to plus or minus 3. Now remember that because you're taking the square root of a variable, you have to remember to use the plus or minus. So then your two intercepts would be 3, 0 and negative 3, 0. And we can leave the way you solve that is going to be up to you. And we have spent a lot of time on factoring this year. So hopefully you are able to do so. There's one more method, and remember if you had x squared minus 9 equals 0 and you wanted to use the quadratic formula. So the quadratic formula, I'm just going to touch on it real quick. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2 times a. Remember, I don't know if you do, but I'm going to remember that, hope you do, that this is an ax squared plus a bx plus a c. Well, here's the a. So the a value is equal to 1. The b value, whatever's in front of the x, there isn't one, so it's a 0. And the c value is equal to negative 9. And if you want to use that quadratic formula, you can just go for it. I've already solved this twice in 2 other methods. Factoring is absolutely, by far, the most efficient method. But if you love quadratic formula, go for it. You'll get the same solution. All right, everyone. The next page in your packet is your homework. It is worksheet number 2, assignment day 2. Find the x and the y-intercept for each one of these. All right. Thank you so much, everyone. This will conclude our lesson number 2. Hopefully.